Good afternoon to all. I welcome you for the lecture series in Production Technology course. So today we have a very interesting topic that is CNC part programming. You all know very well what is CNC. It is computer numerical control. We are going to automate machining process with the help of machining centers as we discussed in the last class. So for that we need to write a program, and that program is nothing but your CNC program. So a part program is a series of coded instructions required to produce a part. It controls the movement of the machine tool and the on-off control of auxiliary functions such as spindle rotation and coolant. The coded instructions are composed of letters, numbers, symbols, are arranged in a format of functional blocks as in the following example. For example, if you are creating a code which starts with N, N10 is a sequence number, G01 is linear interpolation mode, and X coordinate 5 inches, Y coordinate 2.5 inches, and feed rate is 15 inches per minute. So this is the structure of any part program. So what is the information needed by a CNC is preparatory functions, units, incremental or absolute positioning, coordinates X, Y, Z, Rx, Ry, Rz, and machining parameters, feed rate and spindle speed, coolant control on and off, flood, mist, tool control, tool and tool parameters, cycle functions, type of action required, miscellaneous control, spindle on off, direction of rotation, stops for part movement. This information is conveyed to the machine through a set of instructions arranged in a desired sequence called a program. So we will have a sample block format. So here we have a sample block N135, Z01, X1, Y1, Z1, and feed 5. Z is 0.125. So restrictions on CNC blocks, each may contain only one tool move, each may contain any number of non-tool move G codes, each may contain only one feed rate, each may contain only one specified tool. The block numbers should be sequential. Both the program start flag and the program number must be independent of all other commands on separate lines. The data within a block should follow the sequence shown in the above sample block. So word addressing code, we have an example CNC programs. Each instruction to the machine consists of a letter followed by a number. Each letter is associated with specific type of action or piece of information needed by the machine. Letters used in the codes are N, G, X, Y, Z, A, B, C, I, J, K, F, S, T, R, M. Let us see one by one. G codes are the codes which is used for this is called as generic codes. For example, we use G01 as linear interpolation, G02 as circular interpolation, G03 as circular interpolation counterclockwise, and G04 as dwell, G08 as acceleration, so on. G90 absolute mode, and we have machine codes for that the same M00 program stop, M01 optional program stop, M02 program end, M03 spindle on clockwise, M04 spindle on counterclockwise. Likewise, we have M30 program stop or resets to start. So we have N codes gives an identification number of each block of information. It is generally good practice to increment each block number 5 or 10 to allow additional blocks to be inserted into the future are required. X, Y, and Z codes are used to specify the coordinate axis. Number following the code defines the coordinate at the end of the move relative to the incremental or absolute reference point. So I, J, and K codes are used to specify coordinate axis when defining the center of a circle. Number following the code defines the respective coordinate for the center of the circle. I hope you understood what is a basic block of a CNC program and what is the definition of each letter in it. and how we can sequence the same. And we also have F, S, and T codes. F code is used to specify feed rate. S code is used to specify the spindle speed. T code is used to specify the tool identification number associated with the tool to be used in the subsequent operations. So with this, we can write a simple program for any kind of component to be manufactured using a CNC milling center. So we have machining centers, vertical machining centers, and horizontal machining centers, as we have discussed in the previous lecture. With this, we'll close this lecture series and we'll meet in a new lecture series. Thank you all.